My name is Marcin Ogranichuk. I'm currently a sophomore attending East Stroudsburg University, and today I'll be talking to you about my research on the expression of Shikimate Kinase as a potential target for novel antimicrobials. Now, before I dive into detail of our research, I'd like to give a short background on tuberculosis to help viewers understand why our research is relevant. Tuberculosis is an upper respiratory infection that infected nearly 11 million people in 2017, which is far more than previous years. This infection rate is primarily due to the fact that tuberculosis can exist in a variety of forms based on its level of resilience to antibiotics. This rising level of infection rate suggests that there is a need for the development of novel anti-tubercular agents. Now, when searching for a potential enzymatic pathway, it is vital that the pathway contain no mammalian analog. The Shikimate pathway, shown here, is a 7-step metabolic route linking the metabolism of carbohydrates to the synthesis of essential cellular metabolites. This pathway is used by bacteria, fungi, and plants to synthesize aromatic compounds. This pathway has no mammalian analog, thus making it a potential target for the development of novel anti-tubercular agents. Our research is focused on the 5th step of the Shikimate pathway, shown here, which is the phosphorylation of shikimate to shikimate 3-phosphate. This process is catalyzed by our enzyme of interest, Shikimate Kinase, or in our case, Mycobacterium tuberculosis Shikimate Kinase, or MtSK for short. Below is a crystal structure of the enzyme, where you can see the conformationally flexible lid domain, nucleotide binding site domain, and substrate binding site domain. Our initial methods entailed a series of bacterial transformations using XL1 blue cells and DE3 gold cells. These were transformed using PET21B plasmids with an aroK gene inserted into the multiple cloning site. Our first transformation was deemed successful as we begin to see banding around 4100 base pairs, seen here. This is consistent with what we'd expect as it corresponds to the molecular weight of the PET21B plasmid with an incorporated aroK gene. This suggests that our XL blue cells were successfully transformed with the plasmid. Our second transformation entails us using DE3 gold cells. These cells acted as our expression host for Shikimate Kinase. These cells were transformed with PET21B plasmids along with aroK gene inserted into the multiple cloning site. The success of the protein expression was evaluated using SDS page analysis. The transformed DE3 gold cells were used to inoculate a series of lysogenic broths that were supplemented with both ampicillin and chlorophenicol. Finally, Shikimate kinase synthesis was induced by the addition of 1 molar ITBG, and cell growth was monitored over 4 hours by measuring by OD600. Samples were collected every hour, and SDS page analysis was performed. The 4th hour sample was used to perform a TCA precipitation analysis and solubility test, shown here. There is a band of increasing predominance from T0 to T4 through the solubility test around 20 kDa. MtSK has a molecular weight of 19.6 kDa. This showed that the small-scale expression was successful. The bacterial culture was then upscaled to a larger scale for expression and purification. Large-scale expression showed similar results to small-scale, shown here. We note that the protein is being expressed in both soluble and inconclusive bodies, shown here. The protein also appears to be dimerized with a band around 40 kDa, shown here. Subsequently, we purified the protein using nickel affinity chromatography. Altogether, we have successfully cloned the plasmid of interest, and our data shows that the protein is being expressed in both soluble and insoluble forms. We've also been able to purify Shikimate kinase using nickel affinity chromatography. Our future studies will include the steady-state kinetic characterization of Shikimate kinase and evaluating the effects of green sponge metabolites like quinone and derivatives of avarone to determine their mode of inhibition and suitability for subsequent evaluations in drug discovery and development pipeline. I would like to thank East Stroudsburg University Department of Chemistry and Biochemistry, East Stroudsburg University College of Arts and Sciences, and the East Stroudsburg University Foundation Josephine Louis Madura Undergrad Student Research Endowment. Thank you for your attention, and please stay safe.